The technology that Tidal developed and is continuing to develop new features for as we move into the future was essentially two parts, but the main purpose of it is to provide a window into the undersea world so that farmers in aquaculture can make better decisions. And so that looks like essentially two parts. The first is a underwater camera system with multiple different cameras, a winch that moves the system autonomously, so without anyone needing to interfere or manually move it within these large aquaculture pens, currently primarily focused on salmon, which can have up to 200,000 fish in a given pen that can be up to 30, 35 meters deep. And so you have a system that's moving autonomously throughout that pen in real time, capturing video. And then we use AI and machine learning as part of that to interpret and give estimations on real time biomass or the growth and distribution of the fish health indicators, behavior indicators, and we also can connect to feeding systems so that we can actually feed the fish in a way that is really efficient and thereby beneficial to both the environment and also cost-wise to aquaculture farmers so they can be more efficient.
Okay. So what does it look like visually? In practice?
If you look at it in the hardware side, there's a few main components. The first is this underwater camera system that looks like a stereo camera, so two camera eyes in the front and a bottom camera, and then a long tube with a light and a top camera at the top with winch keys, which then connect the system via ropes to the autonomous winch, which is a simple two-part winch that moves the system on a horizontal and vertical axis. And then that connects all the information, sends it to a server, which then connects it to the cloud. And that's where a lot of the actual work and let's say the AI is run.
Right. And this hardware is sort of swimming around the pen.
Exactly. So it's on that winch system, but it's moving all throughout the pen, up and down over the entire course of it all the time so that we get a really broad distribution of the fish that we see in the pen rather than a sample where you're just stagnant in the pen. You wouldn't see as many fish. The reason is often sick fish or fish that are struggling might hang out within the pen in the top, in the bottom, on the sides. And so it's important that we can see a broad representative sample of all the fish in the pens.
So Tyler's platform was named one of the Time magazine's top invention of 2023. Why is the tech so important, so innovative?
Yeah, when we started out now years ago, there was no camera system that could give this type of insight to the degree that we could in a full all-in-one system. And so I think it's innovated on two sides. One, not only does it provide benefits in terms of saving costs and helping farmers to be more efficient in their operations, which means using less resources, which means a better carbon footprint and environmental footprint. But it also has fundamental impact on the way that you operate, and that can impact the environment. So, for example, the feeding software that we developed using AI allows you to basically feed much more efficiently only when the fish are hungry and to make sure there's no feed waste. And the feed waste is not only, or feed is not only 40%, give or take, of the operational costs of a given company, which is huge. It also is one of the biggest contributors to carbon footprint for companies, both in the making of the feed as well as then if you have feed fall through to the seafloor, that can cause eutrophication and environmental damage. And so that's negative as well. And so by being more efficient and connecting that holistically to insights on growth and health and other environmental metrics, it allows us to give this really clear take in this all-in-one system that allows you immediately to have more information, to act on the information, and then to have much more sustainable and efficient aquaculture production.
Very cool. So let's break that down. So you introduced the autonomous feeding feature and its impact and positive environmental impact. What about let's talk about all the other components
Sure.
and with particular interest in the positive environmental impact or any sort of significant impact that it could have.
Yeah. So, for example, let's talk about biomass. So,
Yeah.
before these types of systems existed, you would look into the pen, you would maybe take a sample of, 20 fish, maybe put in more resources to get a few hundred fish out of 200,000, which of course isn't a statistically significant representative sample. And you'd have to make guesses on how many fish you had on the total biomass you had in a given pen. And then you had to guess how much to sell based on that. That meant that you might order a truck to come and maybe you underperformed and you had less fish than you thought you did, or maybe you had more and had to order another truck. And so, in not having an efficient transition from what you actually needed to come pick up and what you actually could plan for, you end up potentially having more waste and carbon impacts with the transportation, and it made for a less efficient system. And so, first of all, you need to know what you have underwater, right? To be able to manage something, you need to be able to measure it.
Is there an element of also knowing when to pick them up?
That's part of it too, exactly. And so, because we know when the fish are growing to a size and you know when you want to harvest them, that means that you can more effectively plan for not only how much to plan for, but how many and when to plan to come pick up the fish.
So it sounded like there was something else. I interrupted.
Yes. So the second piece is we think about health. So health and sea lice is unfortunately something that plagues a lot of the salmon industry. And so it's particularly within Norway, sea lice is a big challenge that's been increasing as water temperatures increase due to climate change. And so because of this, measuring sea lice and being able to monitor and mitigate them is very important. And by us being able to provide automatic counts of those sea lice levels, it allows us to understand where we are at compared to the pretty stringent government regulations that exist. And you can better plan for when you need boats to come and treat the lice. And of course, these boats, they carry their own set of transportation carbon emissions, et cetera. And so being able to plan well and ensure that boats don't come out when they don't need to, ensure they come early and at the right time to prevent having more and more outbreaks, it allows for not only more efficient operations, but it also helps fish health so that you're not pulling fish out of the water, but rather a system is actually counting the fish underwater, which benefits the welfare as well.
It sounds like it's all about efficiency, essentially, and efficiency in reducing waste and in reducing emissions.
Yeah, I mean, think about energy efficiency, right? We turn off the lights in a room when we aren't in the room, and we try to reduce water waste or electricity waste. It's the same thing for aquaculture, where really efficiency in many ways is sustainability, because when you're efficient with your resources, you're not causing waste or using too many, and that is beneficial for the environment.
Definitely. Have we missed any other application?
Yeah, I mean, there's plenty. I think most of them tend to relate to that health aspect. So anything from detecting health concerns so that you can catch and treat those early. And that also helps prevent more fish mortality if you can catch those issues early. And when fish die, of course, that's a big waste in resources, but if also it's a challenge for fish welfare. And so being able to detect, catch, monitor, and respond to that early is important, and being able to track different behavioral tendencies that we do also can give more insights into the health of the fish. And so there's plenty that goes into that, but I think overall it's thinking about growth, it's thinking about health, and it's thinking about efficiency and sustainability.
I believe it was you that said at some point that Tidal was built to see the unseen and, turn something invisible under the surface of the ocean into something that you could understand and therefore manage. Does that mean that you started from a specific problem and then set out to develop an innovative solution, or was it the other way around where you've come across a cool technology and you went out looking for applications?
That's a good question. So, to understand how we went about that journey, I think it's helpful to understand how X, the moonshot factory within Google's parent company Alphabet, works. And so, the moonshot factory is basically this company or the innovation lab, R&D, business incubator lab that exists within Alphabet. And so within that, there's many different projects or moonshots that try to take on huge problems that impact millions, if not billions of lives. And that is at the center of a combination of that huge problem an innovative approach and a groundbreaking technology. And so moonshots tend to be right at the center of all three of those. If you only have two of the three, you may, for example, have an interesting problem and a good way to solve it, but the technology doesn't exist to make that possible yet. Or you might have a cool technology, a really interesting approach, but no real problem to apply it to, which ends up being a bit useless. And so that's why all three of those is important. And within that, we started out and within recycling multiple different projects. And so within the Moonshot Factory, there's this idea of failing quickly and being able to drive true outcomes. And so because of that, there's projects that have happened in the past that have to do with the ocean, anything from seawater being turned into fuel to things around seaweed. And so these learnings from these projects, though they may have gotten recycled or shut down, those all bled into this moonshot around how do we protect ocean health while feeding the world sustainably. And within X, we often have projects, and it's important for us to have lighthouse partners. And so in this case, Mowi, which is the world's largest salmon aquaculture producer, approached us and said, hey, we have this challenge. We're trying to understand more about the health and the growth of fish. Is there something that you might be able to do? And so through finding a key partner, getting that real world experience, of course, we were technologists and had experience with AI and robotics, but we were not fish farmers. And so we couldn't imagine all of the nuances to the challenges that existed there. And so it was critical that one, someone brought this problem to us that and had the experience to tell us how it actually is lived. How is that experience in practice? And so then we could take the tools that we knew to then start to innovate and design solutions that could help resolve that challenge and provide greater insights. And so that's essentially how Tidal came to be.
Right. Well, we'll come back to that because I do want to go deep into the sort of origin story of Tidal and also how the sort of product was developed, which is fascinating. But I want to come back to the tech for a second. Is the tech relatively affordable?
Yeah, absolutely. So I think that there's two ways to think about it. First, the technology was designed for salmon aquaculture pens, right? And amongst aquaculture, the salmon industry definitely is the most industrialized and probably has the most technology from any other species that is farmed currently. That being said, there's more funds. It has 20% of the value within the aquaculture market within salmon. And so for salmon aquaculture, I would say absolutely we've done our very best to make sure that we drive down costs, that it is affordable. And we see that the benefits that we give in terms of the cost savings from knowing your biomass, from reducing lice treatments, from having more efficiency in feeding, then pays back for itself, essentially, so that the cost is absolutely worth it. For other species, for let's say smaller scale aquaculture or other ones, this system is the equivalent of having maybe a Ferrari where you might need a Prius there. And so the hardware itself may be something that needs to be slightly adapted for other types of aquaculture pens or styles. However, the software, once it's built, it's fairly scalable. And so that's what's important to remember is we designed this system for finfish, salmon being one of those configurations. And so we have this product for salmon, but we also have the potential and have done some experimentation and research around this so that we can fairly simply adapt to other species as well in the future.
Yeah, the reason I asked is because emerging aquaculture types like seaweed, for example, seaweed farming, could benefit from this kind of sort of technology. And there's an element of using technology to make data and insights more widely available to enable smaller players and perhaps less wealthy regions or less privileged individuals or groups to access and benefit from aquaculture and the opportunities in aquaculture. And what do you think about that?
I think it's a very good point. I was recently at the Global Salmon Initiative's yearly summit that they have, and a big portion of that conversation had to do specifically with how do we take the lessons that we've learned in the salmon industry and the technology industry as applied to salmon and start to spread those to other species as well. So we had someone from tilapia farm visit and others from different species who were also involved and speaking at this conference. And I think absolutely one of the reasons we started with salmon aquaculture was because they have power and networking, and it takes care of a lot of the baseline challenges so that we could focus on just developing the AI and the right robotics for this. That meant that we could solve the problem with a partner who had the funds to invest in that type of R&D. And then once you have that type of technology, you can start to say, okay, now how do we downsize it, or how do we scale it in the right way so it's appropriate for these other types of aquaculture that may not have the same funding or budgets, but just as deeply need this type of technology so they can be more efficient, so they can be more sustainable, and they can operate in a way that is better for both food security and for the environment. And so that, I think, is the long-term goal for many of these technologies, is how do we start to take this and eventually translate it so that it can be available for other species as well.